All right, all right, all right. Impromptu stream time. So the other night, super tired, couldn't get it, couldn't figure it out, couldn't remember half the things I knew. So we ended it. I'm back now. The next day, took a look at it. I was like about a half hour. I was like, okay, I got this. And then I ran into another wall, and so I took a little break. Later that night, came back. It was done in about 10 more minutes. And in all things in life, if you try to look at it too hard, sometimes it just gets the better of you. So you'll see here I've got deepburner.exe and deepburnercopy.exe. Now you'll also see loaderframework.exe. Now if we run deepburner, of course we get the registration and we are not registered. All right, we got 27 days left. If we run the copy, this program has been damaged, possibly by a bad sector of the hard drive or a virus. Please reinstall it. So if you try to patch it, it's going to detect that. Now the loader framework, you'll notice if I run that, loads, no nag, cancel, help, about, we're registered to default, days installed 3, type null. Doesn't even care that we didn't pass it a value because, well, it's that good. So that works. The only thing that we need to do now is wait for the trial to expire. I'm not going to set the clock forward to try to expire it because that starts a whole other issue. Let me see if I can find that. When I capture 3, there we go. To where here, not that, where are we at? We want to go to C drive, program files, and nobody's watching. That's okay. Not sure where everyone's at, but well, you know, it happens. They'll watch the video at the end. So still got to get it done. Not going to be around tomorrow to do it, so I figured I'd get this up tonight before I go to bed. It is public. Good. I want to make sure I wasn't streaming to myself on purpose. So Ascensoft DeepBurner Pro. On this computer, I set the clock forward, and it goes, oh, your system clock. I don't want to deal with that. That's a whole other thing we'd have to patch and bypass. We figured out how to patch and bypass it, but that would just be extra work that we don't have to do. So here, with the loader, it's good. Starts up, thinks it's registered. We could even go in instead of saying default, FJLJ, and give it a type. But again, more work that doesn't have to be done. So how did I do it? Well, let's see. Was it on this computer or in the other VM? Let's find out. Let's first open up x64dbg. Cancel as administrator so we don't run into that problem. There we go. Let's close this. Don't need that. Recent files, DeepBurner Pro. There we go. And let's see here. So we'll hit run, and we'll hit run again. It should break on virtual protect. We remember from last time we go 5 times, so it's reload, control F9, F8, control F9, F8, and at this point it's unpacked. So what do? Well, we remember our comments, and we remember that do not jump. To make sure that EAX is set, we have a push here from this call, so we need to patch what's in there. If we put a breakpoint there, we can follow that. We're going to do that in a second. And we're going to remember after virtual protect is here. Now I'm not going to put a breakpoint there because it may try to interpret this, and if you put a breakpoint in, it's going to be an int3 byte instruction. Don't want to do that. So what we're going to do instead is now hit run, and we should break right here. And we do. So now we hit enter, follow that. I'll be right back. All right, I'm back, sorry. And if we control A this, it should, there we go. And of course now, it's gonna go into here. Now keep in mind these addresses here, 2B09858. And in here, it's gonna do the default, and this is where we could change it if we want to. And if we remember correctly, I probably don't, but that's okay. Somewhere down here, this one right here, we needed to change to increment AL or EAX, yeah, AL, because that's the same number of bytes. So we could unpack, fix all that, deal with the, oh, this is damaged or changed, or we could change all of these on the fly when the program launches. So what I did was went back to here, where this one goes out. I took note of these 5 bytes. And let me capture this window so you can see what I'm talking about. Just make it small like that. Window capture. 6, sure. Yep, that's it. We'll make this a little bigger. There we go. Move it down. Alright, so here's the old bytes there. Or no, that's the bytes of the other stuff that we don't need. So is this the right stuff? Okay, right. So here's the 52FF, and then we do our jump. And where do we jump to? So this is still within the file. We went all the way down to the bottom. Found some empty space. Come on. There we go. So there's all your import table and everything. Found some empty space, and we began writing right here. And the code that I wrote, let me just grab it, you can see is right here. Copy. Binary paste, and we'll walk through this. So, actually, let's rewind, and we'll just run it real time. Rewind. Are you going to restart? There it goes. Run. 1, 2, 3, 4. Control F9, F8, Control F9, F8. There we go. And we know that we want to jump down to this stuff down here. So let's grab the address of that real quick. Right here, copy address, minus sign, plus sign. And right here, jump to this. There we go. And since the program's already running, it's past the whole it's damaged thing. So now let's put this code in. Binary paste. I hope this is the completed code. If not, I'll grab it. And let's hit F8. So now we're at push AD. I'm going to resend this out. Okay. And so now it's going to do push AD, which says preserve our stack for us, please. All of our register is going to go on. And then you see this move EAX dword pointer ESP -4. If you remember where we jumped to before the do not jump, where this was calling, right here, not there, right here, that's that code essentially, but we know that on the stack at that time, right here now, is the base of code. And we know that we can add to that to get the original memory space. So, or the new memory space, excuse me. Is that right? Yeah, the new memory space where the thing is going to be calling in here. Comments, do not jump in here, and we're going to calculate this address right here So you'll see that this is 535576. So we're going to grab the 4000, and then we're going to add that much to it, and we have 53554E. And if we follow and dump that address, we'll see it there. But let's go to the disassembler. We'll see that it's at our push EDX, actually right here, not right here. And we're going to be modifying these 5 bytes, which is that call just before the do not jump. And we'll go back, and there's a little trickery at the end because we're modifying a push and then we have to get back. But yeah, so now this call is going to call this line right here. That's a little trick. So F7, and when you do a call, it puts your current position where it needs to return to on the stack. So now we have the address of the location we're at -1 in EBX. And I know that I'm going to need some bytes, so I'm going to store those bytes right here. And you'll see this call 26C81BD right here. And we're going to calculate that address by adding 23 to it. If we were to double click right here, we'll see that that is right at +23. F8, now we have that address in EBX. Now EAX is the place that we want to write to. If we were to try to do it right now, we'd get an access violation, so we need to call virtual protect. We grabbed virtual protect from search for current region, I think is it, intermodular calls, virtual protect, hit enter, and we can use it here because it calls its own internal address table. So no matter what, it's going to work. So we can come on back, and for virtual protect, we need our address that we want to change the protection. I'm pushing it twice here just so I have a place on the stack to return the old protection to. And then you'll see here I load into ESI, ESP +4, and ESP +4 is this address right here. Right, yeah, the second one that I pushed. So it's our free space. And then I push that, and that's where I'm going to store the old protection. I'm going to push the new protection, which is 40 in hex, read write, or page read write execute, and then I'm going to push 5 for the number of bytes that we are changing it for. And then I push the actual address right here. The first push, you'll see why we need that in a minute, because after we do this call F8, I need that address back in EAX, so now it's on the stack. I can pop it right back where it belongs. And here's that second one. That's our old protection, which was 20, which is not right. We can't write to it. So now we're going to move into CL, the byte that's at EBX. Of course, that's the first byte of our call here. We're going to test CL to make sure that it's not 0. You'll see I put zeros here. You could have only left 1 byte, but I left 2 just for prettiness. And jump if equal down to pop EAX. So it's not 0. It's now going to move that byte into EAX. So you'll see down here that it's modified now. And then we increment both of them, jump back, and repeat. So we're writing these bytes to our spot over here. Bloop, bloop, bloop. You'll see this time the last one there. And now CL is 0. We're going to jump out. We're going to pop EAX just to clean up the stack, put it back where it's supposed to be. I don't need this. I don't plan on restoring the protection because we don't have to. If the program was picky and tested like that bit of memory to see if it was modified or its execution policy was modified, then we would just restore it. As soon as we're done, we just flip it right back. But we're not. I'm being lazy. We're popping it off. We're going to restore the stack. Then we're going to move. This is the instructions that we overwrote, the 8, 9. I didn't write it down here, but the ones that were up here before the jump. So we got to do those. Oh, come on. Before we return back So that's what was here. And before we come back to do this call, we need to do those things. So that's exactly what we're going to do. We're going to move that, push 0, jump back, resume execution. And you'll see now, if we go to this address, copy address, go to, we'll see now we have a call here instead of everything that was there. So if we press enter, you'll see that it is this next bit down here, the next function. I'm going to put a breakpoint there because we're about to jump back and resume execution. Let's go to EIP, and yeah, so we're on that call. I'm going to hit run. We should break right here, and we do. So what's different? So now we're calling it from right here, and we have this address on the stack. See? And since what was going to be called, right, jump here, yeah, what was going to be called here is now going to be our own thing, and we're going to go in and modify that. So here we go. And you'll see that I end with a call to it right here because we overwrote that call. So first thing we're going to do is preserve our stack and, well, our registers. And then we're going to move to EAX, what's at ESI plus 4, the D word that's at ESI plus 4. And why am I doing that? Push, push, pop. Oh, yeah. So eventually, or right up here, oh, come on, go back. Go to this guy here. So when you get here in ESI is the address space of where that call is going to be. Hence the calling ESI plus 4. And so we're overriding ESI plus 4. So now we're going to move into EAX ESI plus 4, the address that we're about to call. And so now we have that here. We're going to push it once to give us some space, twice to give us some more space. Then we're going to pop EBX, so we're putting it back into EBX. And then we know that where we want to modify, so if we follow this in the disassembler, which that's not an accurate address. What is this? Oh yeah. So let's load in EAX. This guy here. I think I got some wires crossed here. We'll find out. We're gonna push because that doesn't seem like an accurate space. Call versus this is probably gonna fail. Yeah, invalid parameters. What? ESI plus 4. What did I mess up? Push AD, ESI plus 4. That's what we should have here. So I'm overwriting. Yeah, I overwrote that call, which goes to it. So we just did a call, ESI push AD. Something got messed up. Let me grab that. Let me compare that to the actual code. Let's take a look here. Oh, you can't see anything. Do not see what you're trying to do. Only see your text. Thanks, Phelps. I should look at chat more often. Well, it's a good thing we're starting over. Ah, geez. So not ready for that. My bad. It's supposed to switch to my active window, but it definitely wasn't. So the last half hour, yeah, 15 minutes, just ignore it. Oh boy. Okay, so let's get back to work here. I just showed the whole thing. You didn't see any of it. Awesome. And my stream says offline. Let me refresh this. I don't believe it. That looks correct. Yes, reload. Jeez. Oh, now it says I'm live. And it says there's 3 people watching. Okay. So let's start again. Here's the code. Let me switch to the right view, not that one. There we go. Let's actually look at it this time. So I'm going to rewind. We're going to start completely over here. Take 2. And let me do this one more time. Okay, so F9, we're at virtual protect, control F, or no, F9 a bunch of times. Of course, we have to click to get focus. Control F9, F8, control F9, F8, here we are. And this is after virtual protect. So let's go ahead and comments. We remember these from the last stream. We have our do not jump. We know that if we patch this call that is used to push EAX right here at ESI plus 4. When we get to this, the call inside of that is responsible for returning whether or not we're registered. So here we go. I'm going to control A real quick. There we go. And we'll come back and we need to get ourselves some space. Down here at the end of the file, there's lots of empty space like this right here. And we're going to use some of that. I'm going to grab an address here. I'll just grab this one. Copy address. And here, we're going to do JMP EBP1CEAX JMP that address. And then at this address, this is the code that gets patched in. Let me just go ahead and paste that, binary paste. Control A, and you'll see that the first thing we do is push AD. So let's go ahead and F8, so now we're down here. And we're going to put all of our registers on a stack so that we can change them and use them, and then put them back in the stack. Now, after doing some research, you'll find that the base address of the code where we need to patch is right here. And if you just run to right here and look at the stack here, and then you go to that call, which we'll see in a minute when we get there. Actually, I can show you right now. Comments, because it's right here, do not jump. We'll see that this address space is this, but at the very beginning it's 401,000. So it's base of code plus 1,000. And so we know where this begins. We can calculate where we need to go, which is right here. Well, right. Where's our push? Right here. These 5 bytes, push EDX, those 5 bytes is what we're going to patch this time. Or the next time. So we'll come back. And come on, there we go. So we reserve it, and we see that the basic code is at ESP -4 right here. And so I'm going to move that to EAX. And then I need to add this much to it to get down in that address space to where we're going to patch. And you'll see that that's right here. Follow it in the dump. We can see it right here. If we were to follow that in disassembler, we see it's right here. And then this call, it calls the very next address, E8 and 4 zeros, because calls work with call however far away you are. And so I'm going to call the next address, because when you do a call, it automatically puts where it needs to return, the return address, on the stack, as you see there. So now I can pop that into a register and know exactly where I'm at. So now EBX is equal to our EIP minus 1. So I know that if I go here, I put a call right here, that's just for reference, it never gets ran, at plus 23. So you'll see that I pop that, and I'm going to add 23 to it. Now we have that address right here. And then the next thing we're going to do is push EAX once and then twice. 1, just to make some space on the stack. 2, because we need to get it back when we're done with virtual protect here. And so now we're going to go load ESI, ESP plus 4. And of course that's right here, the address of this spot. So it's going to put 14D74C in ESI. And then we're going to push that. That's the address we're going to put our old protection at. We're going to push our new protection, which is 40, with the number of bytes, which is 5, and the address we want to start at, which is where we're going to be making our modifications. Call virtual protect, error success, all good. And then we pop our modified, or our place that we are going to make our modification back in EAX. So now EBX contains this address here. We're going to move that byte into CL. You see E8. We're going to test to make sure it's not 0. If it is, we're going to jump out to this here, bypassing all of this. And then we're going to move that byte that's in CL to this byte here that we're patching, E8. We're going to do that for all of them until it matches 0, 1, because the next one is going to load in a 0, 0. And test will fail. We'll jump out. We pop our old protection to clean it up. We put our registers back where they were when we started, and we carry out the original commands that we overwrote. Then we jump back. And now, if we go to this address, copy address, we'll see that we have a call to our program right here. I'm going to put a breakpoint right here and hit run. And now we are here. So our stack contains whatever it was doing before, and the registers contain whatever it was doing before. And what it was doing before was push EDX, call deward pointer ESI plus 4, push EAX. I feel like it's supposed to push EDX. Is that correct? I know that it works, and I tested several times. I think there's a reason for that. We'll find out when we get there. So ESI plus 4 is going to be the call it's about to do, and ESI currently contains this. And if we follow in the dump, well, let's do F8. There we go. And now we're going to move into EAX ESI plus 4, which is that call location. Let's follow in dump address ESI plus 4. We'll see that it's here, and that looks much better than the last run. And if we follow in disassembler, we see that that is in fact that call, and this is the call that we need to get to eventually so that we can modify this byte right in here. Where's it at? Right here. Nope, that's not it. It's down further. This one right here to Inc AL. So I'm going to double click this and go back, and you'll see this call is in the same address space, minus 72. So we can get to it with the information that we have now, because we have the location of that call, and we're going to put it into EAX. Boom, bang. And if we follow that in the disassembler, we'll see there we are. And we know that plus from here, a certain amount will get us where we need to go. So we're going to push EAX so we have it later. We're going to push it again so we have some space. Well, we're going to push it for later, and then we're going to push and pop it into EBX because that only takes 2 bytes, and move is... Actually, I think move would be just fine. Let's see here. Move. I don't even want to do it. I'll do it down here. Move EBX EAX. Yeah, it's 2 bytes as well, so the push pop didn't need to happen, but whatever. Restore. Okay. I was in a pushing and popping mood, so that's what we did. We're pushing and popping. Yeah, I don't know. Anyways, EAX, now we want to subtract 66 from that. So from the EBX and store it in EAX. We're going to do that now. And you'll see that it is now this address. We follow that into assembler, and guess what? There's our byte that we need to patch. Woo! The crowd goes wild. Okay, anyways, we're going to push that onto the stack. And then we're going to load into ESI, ESP plus 4. Because that's going to give us this location here. Boom. ESI now contains it, or a pointer to it, rather. We push. Did I do that wrong? ESP plus 4. My bad. Yes, it is correct. We're putting it in ESI. Wait a minute. Oh yeah, that's just our location of our old protect. No more late streams, right? This is the final. It works, and we're just explaining it. Already figured it out. Going through it. We have a game plan, so I don't have to do this tomorrow. So we're going to push that location, which is right here, so that we have a place to store our old protection. I'm just recycling that. Our new protection is 40. Number of bytes, 1 byte. Push our address, which is this guy right here. If we follow that in the dump, which is going to be right here, following dump, 84CO, and to change that from what it is to an increment is an FE, and you'll see that right here. So now we're going to call virtual protect. Boom, success, we're good. No change in errors. EAX is a 1, so good. Now we need to pop that address, so remember we put it on there for later for a reason, and we're going to move to that byte and FE. And if we watch here closely, it's going to change FE, and if we go to it, following assembler, we now see increment AL. So now we're going to pop our old protection, or our new. Oh, the old, it was already unprotected, so we would have been fine to write to that one, but it's better safe than sorry. But it was already virtual protect 40. Didn't have to. Could cut out this entire calculation. Well, not the entire calculation because we need it to do the writing, but this whole call here. Yeah, anyhow, who cares? Better safe than sorry. Access violations are not fun. So we pop it, we clean up, we put our registers back where they should be, and then we remember it was push EDX call, but what does a call do? A call returns to the top of the stack. So when we push this, it's going to return here. So I need to do the next step as well, and then return back. So our original return call, which was here, it needed to do a push first, and then a call, and then a push. So now I need to do that call, and that's why it's push EAX. I'm redoing that, and then the return value is essentially what we need to get back to so that it resumes at the right location. So I'm going to hit F8. We're going to do that call. EAX is this, so AL's 1. Good, it worked. Increment jumped over. Good. Now we're going to push that value, and now we have to push the original return value, which is currently at ESP minus 14 because we popped it off a while ago right here, and that's our return because it always returns the top of the stack. So we have to make sure we clean up the stack, put it back where it's supposed to be, push the value of the return, then push the return so that we can return to the right place and resume execution where we're supposed to. Now if I hit F9, everything's going to just load up magically, cancel, help, about, registered to license to default. We're good. So if you didn't follow that, definitely rewatch the video, go through it line by line. The first half might be fun to watch now. You've seen me go through it. I give you a blind example at the front where all you can see is my notepad, which doesn't do you any good. So yeah, it took me a little while to write all that code, but essentially what we're doing is real-time patching a program to real-time patch itself after it's unpacked different places. That's a mouthful. And of course, we can't save this to the executable. Nope, because if we save those patches, you end up with this file is damaged. So what do we do to patch it real time? We make a loader. So here we go. And here's the code. Of course, the loader framework, which I don't know if I put it in Discord. If I haven't, I'll do it right after this video. Let me check. It's either in Tools. It might be in Tools. Let's see here. Can we search this? Ooh, loader. Don't see any results in there, so if it gets in there twice, whatever. I'll put the loader framework file in there, and this is what we can use to make loaders in the future. It's not anything too impressive, but first and foremost, we need to start a process. So startup info, process information, and set those things with zeros, and then initialize a process. We then use create a process to start deep burner, and if it doesn't work, we say create process failed. We resume the thread, so it's running, and then we have some initialization here. I've got a buffer of 32 bytes, initialize those with zeros, and then I have my patch 1, which we know is the jump to right here. Let's just click that and double click that. Jump from, show references, go. There we go. So that's right here, E9AF8D01. That's our first patch, E9AF8D01. And then the OO. Why did I do an OO? Oh, you can't see this because it's on a different window. Damn it. Cancel. Okay, so right here, this is our E9AF8D00. This is where we jump to our code that we're going to be going. So we need to patch that, and then we need to write this whole patch, and then we're done. So we need this address here, and we're going to be replacing whatever's there with E9AF8D00. So then at the bottom of the file, we have our entire code, which is the 6.0, all of that. And then T1, I don't think we're using this at all. No, this was for the old one where we needed to continually watch until a byte was written with whatever we put in there, test 1, and then patch it. That was for GR level 3. Then the size T bytes is 12, garbage 12, great, old protection, great, we got it. And we're going to do virtual protect at that address right there, which is in our file. We're going to ask for 5 bytes, set it to 40, old protection goes here. Then we're going to write our patch 1, and then we're going to restore the old protection. And then at this address here, which is where this one's jumping to, at the bottom of the file, we're going to write our entire code here. I was just looking to see E9AF8D01, which would be 01-8DAF. It's the distance from, so that's just interesting. Anyways, we're asking for 113 bytes. That's how long this is. So 113 bytes of code. And we want it to be 40. We're going to save the old protection. We're going to write our patch to it, and then restore the old protection and return. So close our loader. And then we're good to go. I compiled this project options compiler. Let's see here. Strip executable. It does still create a console window. I tried doing it without creating console window, but for some reason it wouldn't write. So not sure why. So I left that out. I think it flashes for a brief second. Let's pull it back up over here. There we go. And let's close this. When you compile and run it, yeah, brief second, and boom, we're good. So it starts it, patches it, writes our code. When it gets to that point where the spaces that need to be patched are available, we have where it needs to be. Our code grabs that, patches those bytes to call back down over here when the next space is available, and we can grab it off the stack. We grab that space, we calculate those, we patch the 1 byte, and then we resume normal. So now, without changing the file at all, technically, we have it start up, get patched, then patch itself. It's kind of cool, kind of fun. But yeah, that is how it's done right there. The code line by line for the assembly. Let me just pull that back up here real quick. And I'll just put it right here, I don't care. Binary paste. Make this a little bigger maybe. Of course we can't. Oops. There we go. Doesn't quite all fit. You'll have to scroll the window a little. Maybe I can move these. I don't know. No. Does F12 work? No. Anyways, can't make it any bigger to show you. But the start of the code is here. Push AD. Comes on down to right there. And then, of course, it patches the jump up there. And it's good to go. We'll close this. Cancel. Closing the virtual box on accident. There we go. So now we'll go back to the other window. I'll show you the C code. And of course, somebody's going to complain if I don't do this. Look, it compiles. And C drive. No, it's on desktop. Loader framework. I'm going to grab this and put it in the thinger right now. Loader framework. Add to archive. Loader framework. Zip. Okay. So this is a framework it's a basic framework you can use to make a loader. It's got a little loop in there if you need to detect a byte first. It's really nothing special, but just in case you don't want to write it all yourself, it is in the tools section. Right. Oh, come on. Let me just do this. Downloads. I thought I could copy paste it, but no. No, that's not what I want. Downloads. Now I can grab it. Loader framework. And that is in the tools section. Basic framework to write a loader. There we go. So that's in there if you want to grab it. And the Discord chat tools channel. And then, of course, just to prove it is actually running off of that, I'll grab that framework out of there. Let me grab the other VM. // 192.168.0.137 downloads. Loader framework. Run. Oh, that's not it. I need the zip. I was like, what? Oops. Outputs. Loader framework. 513, 1021, 2 minutes ago. It's compressed at 3 kilobytes. It's 8 whole kilobytes itself. This PC, C drive, program files, AstonSoft Deeper Pro. We'll overwrite this one, replace it, continue. run it again. And of course, if we run the exe registration, we have days left, stuff like that. Unregistered, days installed. Copy, this is if you save the patch. Nope. Loader framework. Yes, I trust the file. Runs, and look, we are registered to default. Don't care about the type. Days installed 3. Not days left, days installed. There you have it. So that one was actually really fun. There was a lot to learn. If you watch it from start to finish, you'll see the frustration, you'll see the learning, you'll see the finding. And on this one, I'm sorry it wasn't written real time. When I was working on it, I didn't really have the means to stream it. So I've got it put together here. Showed you line by line how it worked, what it does, and then showed the code for that. If anybody has any questions, jump in Discord, ask me, and I'll get back to you as soon as I can. Other than that, I hope you guys enjoy your night. Have yourself a fantastic week, and we'll see you next time.